Dear students, good morning, good afternoon, good evening. How are you? I hope best for you. I Mukesh Kumar welcomes you to online Mukesh Online Academy. आपका मुकेश ऑनलाइन अकेडमी में स्वागत है. And we are doing the science of class 10 and we are doing chapter 13, that is the magnetic effect of current, means magnetism we are doing. Okay, so we started this chapter and we have done into the one video. Okay, we have already covered the one video, the introduction part. Okay, in that part we studied about how does the current can produce the effect of magnetism by doing an activity, and we did about the different aspects like what are the magnets, what are the properties of the magnets. That introduction we did in the last video. I hope you would have seen that. If you have not still seen, go through that video. Okay, I have given the links into the description. My every videos are in connection with the first video. They all have the links. So okay, so if you watch that video before, so you will be able to understand this video in a much better way. Okay, and one tip, just take out your notebook and pen and start making the keynotes. Okay, so whenever you watch any video, study related video, make the key points, make the summary. Okay, this will help you to revise into the exam, and I hope you would have seen my videos of the previous chapters. Okay, so in which I have suggested the same thing, so you must be doing that and you must be making the summary of that. Okay, if you have any query, if you have any doubt, then you can write to me on the WhatsApp or email and we will be happy to solve your doubts. And just WhatsApp me for the notes free of cost. The notes of all the chapters along with the practice questions are waiting for you. Okay, just mail us or just WhatsApp us. We will send you the free of cost all the notes and practice questions. Okay, and I hope you must be getting knowledge from my videos. Kindly share it with your friends, subscribe to it, ask your friend to subscribe. And in this video what we are going to do about the permanent magnets, artificial magnets, soft magnets, what are the different magnetic materials of which the magnets are made of. Okay, and that we will cover into this video. So now let's do it. So in this video we will do the magnets. Basically we will continue with the magnets. In the last video we had done what is the magnetic effect of current, who discovered it, and what are the different characteristics of a magnet, that we had discussed into the last video, into the introductions. Okay, and what is the magnetism. And now in this video we are going to cover what are the permanent magnets, okay, soft magnets, artificial magnets, that we are going to cover. So now the first we will do the what are the permanent magnets. Okay, so number A, we will do permanent magnet. As the name suggests, permanent magnets means the magnets which do not lose their magnetism. Once they get their magnetism, it is not very easy to lose the magnetism. So we call them the permanent magnets, like bar type magnets, U magnets. So these are the permanent magnets that we find into the laboratories. Okay, so now let's write it. Magnets which retain their magnetism for a long time are called permanent magnets. Okay, so they are made from certain alloys of iron, nickel and cobalt. So these three things are the magnetic materials. Okay, made from certain alloys of iron, nickel and cobalt. Okay, and these materials are called the hard magnetic materials. Why? Because they retain their magnetism. The soft materials do not retain their magnetism. Okay, so the materials used to make permanent magnets are called hard magnetic materials. I hope this is clear to you. Okay, so we have different alloys of which they are made, usually made of alloys such as carbon steel. See, carbon steel means when some up to 1% carbon is mixed into the iron, it becomes the carbon steel. Okay, chromium steel. Okay, when chromium is also mixed like the stainless steel. Okay, cobalt, tungsten steel. So it is made up of cobalt and tungsten. Okay, nipper mag contains the nickel, aluminium and titanium. Other is alnico contains iron, nickel, aluminium and cobalt. Okay, and these magnets, if we make the permanent magnet from these materials, so they are much stronger than when they are made from the ordinary steel. Okay, the permanent magnets made from these alloys are much stronger than made from ordinary steel. I hope this is clear to you. Now, where are the permanent magnets used? Basically, we use them in the loudspeakers, microphones. There are many uses that you can find surrounding yourself. Okay, so they are used in loudspeakers, microphones that we use to record the voice or to speak. Okay, televisions, stereo speakers. There also the permanent magnets used in refrigerator doors because it just close automatically. Okay, because it contains the magnets. In refrigerator doors, on audio and video cassette tape. You know, around 15-20 years back there used to be audio cassettes and video cassettes. Okay, on which we used to watch the movies in the video cassettes and listen the music on the audio cassettes. Nowadays they are into the museum, you can say. Okay, because now they are outdated, so they have been kept into the museum. But previously these magnets were used on these video cassette tapes. On hard disk still they are used. Okay, and floppies. You know, nowadays we have the pen drives, CDs, DVDs. Around 20 years back, there used to be floppies where we used to keep a lot of data, but not lot of data. Rather, I will say nowadays CDs are of 700 MB and this one floppy was just of 1.4 MB. Okay, so CDs and DVDs and the pen drives have changed the way that we used to store the data. So now the floppies are no longer used. Floppies for computers, but they were used previously. Okay, in children toys, ammeters, voltmeters, speedometers, electric clock, electric generator, electric motors, MRI means the magnetic resonance imaging. So there are so many uses of the permanent magnets. Now let's repeat it. See, the permanent magnets are those magnets which retain their magnetism for a long time. Okay, so they just don't lose the magnetism in a very short period of time. They are made of alloys like iron, nickel and cobalt, like carbon steel like nickel and cobalt. Okay, and we call them hard magnetic material because they retain their magnetism. They are made of the carbon steel, like when the carbon is mixed into the iron, chromium steel, cobalt, tungsten steel. Nipper mag contains the nickel, aluminium and titanium. Alnico, like iron, nickel and cobalt is there in the alnico. Okay, and if we make the permanent magnet from these materials with that which I have described here, okay, then these are very stronger than made from the ordinary steel. And they have so many uses, like they are used in loudspeakers, microphones, televisions, stereo speakers, in refrigerator doors, in audio and video cassette tapes, and hard disks and floppies. Okay, for computers that we use. In children toys, ammeter that we use to measure the current, voltmeter that we use to measure the potential difference, speedometers that we use to measure the speeds, okay, electric clocks, electric generator, electric motors, MRI, and many more, okay, which we have not written here. So there are so many uses of permanent magnets. I hope this is clear to you. Now the soft magnets or temporary magnets. We have soft magnets or temporary magnet. Okay. See, as the name suggests, temporary magnets means they do not retain their magnetism for the longer period of time. So they just lose their magnetism very easily. So that is why we call them the soft magnets or temporary magnets. Okay. These magnets are magnetized when placed in a magnetic field, but lose their magnetism once the magnetic field is removed. Like you can see that if we make the electromagnet, okay, so that is a temporary magnet. Clear? Example, electromagnet is the temporary magnet that we will study later, okay. And suppose if we keep an iron nail near the magnet, so this iron nail also gets magnetized, so it can also attract the pieces. And once we remove that magnet, the iron nail just no longer remains the magnet. It loses all its magnetism. So this iron nail was the magnet till it was in contact with that magnet, okay. And once that contact is removed, then it lost its magnetism, okay. And we call these materials soft magnetic materials, okay. Materials used for making these magnets are called soft magnetic materials, okay. I hope this is clear to you. Now let's repeat. So soft magnets or temporary magnets are those magnets which are magnets till they are in contact with some magnetic material, and once that magnetic material is removed, then they also remove their magnetism. Like the electromagnet, okay. So when we flow the current, then it becomes a magnet, and once we just switch off the current, then it no longer remains a magnet. So electromagnet is an example of a temporary magnet. And there is one more example. Suppose if we just bring some iron nail into the contact with the magnet, so it gets stick to that, means it also requires that iron nail also acquire the magnetism. Once we remove the magnet, then this iron nail no longer remains the magnet, and we call these magnetic materials as the soft magnetic materials, okay. Now next we will do artificial magnets or man-made magnets. See, we have artificial magnets or man-made magnet. See, natural magnets are also present, but they cannot fulfill all the requirements of the human on the earth. So normally in the laboratories for the practicals and for different uses that we have just studied, okay, the artificial or man-made magnets are used. How they are made? They are just by rubbing with the magnetic materials. Some materials are rubbed against these magnets, and these materials also acquire the permanent magnetism, and they become the magnets. So that is why we call them man-made magnets or artificial magnets, okay. So now let's write it. When natural magnets are rubbed against iron and steel bars, okay, the same property of attraction is communicated to these bars, means they also gets magnetized, okay. And these magnets are called artificial magnet. Example, bar magnets, horseshoe magnets. Horseshoe means U shape, used in laboratories, used in physics labs, okay. And these are made from the iron, certain steel and nickel alloys, made from iron, certain steels and alloys. Like the same one that we have learned into the permanent magnets. So same materials can be used for the artificial magnets and man-made magnets. So now let's repeat. Okay, artificial magnets are those magnets which when we rub the natural magnets against the iron or steel bars, okay, then the property of the natural magnets also gets communicated to the iron and steel bars, and they also gets magnetized and they also becomes magnet. So that is why, since they have been made artificially, so we call them artificial magnets. For example, like bar magnet and horseshoe magnet that we use in the physics labs for the practicals, these are the example of the artificial magnets or man-made magnets. And they have the same, almost the same magnetic materials of which the permanent magnets are made, like iron, certain steel and alloys. So this is the example of the artificial magnets. Okay. So what are the magnetic materials of the natural magnet? It is mostly the oxides of iron. Okay. Magnetite basically. The natural magnets are made from magnetite. Magnetite is basically the oxide of iron. Okay. Black colored iron ore. Okay. Now we will study about the bar magnet. Normally in the laboratories we find the bar magnets. Okay. So the question is, what is a bar magnet? Okay. So now we will study about the bar magnet. Bar magnet means the rectangular bar, cuboid shape, like this shape that you can see that. This is the shape of the magnet. Okay. And this is normally painted, this portion is painted red. This is painted red. Okay. And this is painted either green or white. Okay. So this is the north pole and this is the south pole. Clear? Normally the north pole is painted red and other is not painted, or other is painted in the blue also. Okay. So we can see the bar magnet is a rectangular bar like the cuboid shape, which is having the magnetic properties, in which the two poles are present. One is the north pole, other is the south pole, and we use them in the science laboratories. Okay. A bar magnet is a long rectangular bar of uniform cross section. Here you can see the cuboid shape. Okay. Which attracts pieces of iron, nickel and cobalt. Okay. And we use them in the science laboratories for the practicals. They are used in science laboratories for performing practical. I hope this is clear to you. So bar magnet is just like a bar shape, or you can see the rectangular bar, or you can see the cuboid shape. Okay, where when one pole is north pole, other pole is the south pole. North pole is generally painted red and other pole is generally painted either white or blue, and that is the south pole. Okay. Now if we break the bar magnet into the two pieces, and again further they are broken into the two pieces, so what will happen? Will they still retain their same poles, north and south poles, or will they lose their south poles? Now let's see in the form of a question. See, we have a question. What will happen if the bar magnet is broken into two pieces, and if each piece is further broken into two pieces? Like this. Suppose this is the bar magnet. Okay. North and south. Suppose if we break it, then one piece is this, then other piece is this. So what will happen? This pole will remain the north pole and this will become south pole. And this pole again will become north pole and this will become south pole. Means south and south pole will remain and the other pole becomes south and north. If we break this further into two pieces, okay, then again what will happen? So this will be north, this will be south, this will be north, this will be south, this will be north, this will be south, this will be north, this will be south. So this will keep on going on till we get a very minute particle. That will also still have the north and south poles. Okay. So now let's write it. When a bar magnet is broken into two pieces, then each part we have as a complete magnet with two poles, north and south. Okay, if each piece is further broken down into two pieces, then again each piece will behave as a complete bar magnet with two poles. Okay, so now let's repeat it. Suppose if we have the bar magnet and we break it into the two pieces, so each piece will behave as a complete magnet having the two north and south pole, although its magnetism will be reduced. Okay, and suppose if we further break it down, then again the two new short magnets with the having north and south pole will be, and if we further broken down, then also they will just have the complete magnets till it becomes even the minute particles. Okay, so I hope this is clear to you. So dear students, in the next video we will do the compass needle. Okay, what is the compass needle, what are the uses of it, okay, why does it deflect? So we will do on the compass needle. We will do about the magnetic field, and we will do something about the magnetic field lines. So these three topics we will cover into the next video. Thank you so much for your watching. Write your comments about the video, any query, any doubt about the topic in the comment box, or you can write to me on the WhatsApp or email also, and just WhatsApp me or just give me a mail for the notes, the free notes. The notes free of cost are waiting for you. Okay, just give me the message on the WhatsApp and we will send you the notes related to this chapter and whatever other chapters are there, free of cost. Okay, so don't lose this opportunity. Okay, and I hope you must be getting knowledge from my videos. Kindly share it with your friends, subscribe to it, and just comment how did you like this video. Okay, and share it to your friends, subscribe to it, ask your friend to subscribe. Thank you so much.